Hi, folks. Thanks for coming to this webinar. I hope you've been enjoying April, but let's take a quick look at the past March. There's still a lot of research going on, but we can see if we start looking at some of the stats that most Arizona counties really had some records. Most Arizona counties had seven or more maximum temperature records specifically. Every Arizona county had their hottest March on record. Many stations had their hottest March temperatures ever recorded. So let's just touch on a few. That included Yuma with 109 degrees, Phoenix 105 degrees, Tucson 102 degrees, and Flagstaff 84 degrees. These March temperatures were roughly 2 months ahead of the average timing for those temperatures in Arizona. And so now we're looking at this. An anomaly, just a reminder, it's a departure from the average. So, for example, how many degrees it might have been hotter or colder than normal. So, if we look at March 19th to March 21st, Phoenix saw anomalies that were nearly 20 degrees above the average temperature. And just a reminder, an average temperature is calculated by adding the hottest temperature of the day to the coldest temperature of the day and dividing by two. So that's the average temperature. And it's a really good thing that dew point temperatures were only in the 20s and 30s last month because that really helped keep the night temperatures more moderate. And now looking at what we had for precipitation, Arizona really only had one significant precipitation event in March. That was a low pressure system that mostly impacted what was going on in the southeastern counties. The rest of the state was really dry. Here's some perspective. So Phoenix had 6/100ths of an inch of precipitation in March. But that actually made Phoenix wetter than Flagstaff. Flagstaff only had 4/100ths of an inch of precipitation in March. So that really doesn't happen all that often. And just an FYI, every county in Arizona was below the average precipitation for March. So now let's look at the last 12 months. The last 12 months ranked as the hottest April to March on record for Arizona. Three of those months were also the hottest months recorded ever in Arizona. So if we look at the lower 48 states, that's called the CONUS, the past 12 months were the hottest 12-month span ever recorded for the lower 48 states. Those records go back to 1895. So it was a tremendously warm time frame, especially the last 12 months. If we look at our precipitation, fortunately, 5 of the last 12 months were wetter than average. So for Arizona, you can see those green months. So we had May, June, and then September, October, November. So for perspective, when we look at those months, May and June are statistically the driest months of the year for the state. And then we pop over into fall, October and November are statistically the fourth and fifth driest months of the year for Arizona. So seeing above average amounts for the month is great, but it's still not a lot of overall precipitation. So now let's pop into the water year. The water year is now below average for the state, and you're looking at 5.29 inches of precipitation for the water year to date. The water year starts in October and ends in September, and those numbers come from statewide precipitation looking at October 2025 to March 2026. The exceptionally wet October, November last year really skewed the water year numbers. So if we look just at the past 4 months, so let's go from November to March, only Cochise County had above average precipitation for those months. If we include the wet fall from last year, so October, November bringing in, only two counties are above average for the water year. So that's again Cochise County and now Santa Cruz counties. And they were really helped out because they had a very wet January. So now let's take a look at the total Colorado Basin. So that snowpack usually peaks around the 1st of April or so. Snowpack has been measured in the Colorado Basin since the 1980s, and it's measured as SWE or snow water equivalent. Arizona set a new record low SWE this year. Arizona usually gets good snowpack statistically December and January, and sometimes even in February and even in March. But that really didn't happen this year. Arizona's snowmelt started almost a month earlier than normal, and Arizona's peak SWE was about 4.63 inches below the median SWE for Arizona. Lower snowpacks really affect several arenas, and that can include things like agriculture, energy, water supply, obviously, and recreation. So, not only Arizona, but the West and the Southwest have been paying close attention to these numbers. Short-term drought conditions. So, you can see that short-term drought has changed. So, we're looking at 2024, 2025, and present 2026, kind of all in the middle of April. So short-term drought conditions have degraded this year since March and April. Moderate short-term drought has advanced in northern and central counties, and severe short-term drought has expanded this month. And you can see that across Pima, Pinal, Maricopa counties, and go up and you can see it along Greenlee, Apache, and parts of Navajo County. Arizona, like we looked at, is somewhat better than this time last year. They were a little bit worse off. But compared to 2 years ago, we're back in a more degraded time situation. And then kind of looking at how Arizona evaluates long-term drought, Arizona uses SPEI blends. SPEI stands for Standardized Precipitation Evapotranspiration Index. And so what that means is it takes into account hotter temperatures because hotter temperatures make a thirstier atmosphere. It affects our drought. You can see that the last 60 months, so let's pop back April 2021 to March 2026. If you add all of those records together, compared to other years, Arizona had the hottest past 60 months on record and the 25th driest on record. But here's the good stuff, right? Here's what we all wanted to see, the CPC outlook for July to September. It's exciting to still see that above average precipitation outlook for the monsoon. So that's even gotten bigger. The CPC continuing to expand their outlook for the monsoon. And, that outlook for a wetter monsoon, as we've talked about, it comes from having drier soils, below average snowpacks in winter, because that really can help with the monsoonal flow. And everyone will keep watching to see the ingredients come together. And we're grateful that we have a great guest speaker, Mike Crimmins, to talk about these kinds of things. And our last slide that we're going to look at here is understanding what's going on with ENSO. So CPC now confirms ENSO neutral conditions are present. And there's a 61% chance that El Nino emerges May to July of this year. Just a reminder, El Nino, that's the warm phase of ENSO, and it tends to move the storm track kind of more to the southern US. What that means for Arizona is that Arizona has a better statistical relationship between El Nino and winter precipitation. So that'll be really interesting to watch too. I'm really grateful that everyone is here to learn about these ideas and to talk about these ideas. You can find the latest information and details about Arizona's weather, water, and climate. Go to our website, azclimate.asu.edu, and you can also see links to our previous webinars there. So I'm going to go ahead and stop sharing now, and we'll get our guest speaker on who's going to have some Mike, you're going to have great things to talk about, right? Micromans.
I hope so. I hope oh man, that was rough, Aaron. And man, we all lived through this spring so far, and it's inverting itself again. We're getting cooler and wetter now, which is strange pattern in the last couple of years. Thanks again for having me. I'm excited to talk about the monsoon, even almost 2 months to the day early. And what I want to try to do, I've got too much stuff, of course, to try to cram in 15 minutes. But what I want to do is just spend a couple of slides getting us all on the same page about some of the big circulation features that we want to look at when we're thinking about the monsoon coming up into June and into July. And so just to draw the contrast real quick, the weather patterns that we see here in the Southwest really are very different from the winter to the summer. And in the winter, we participate in the mid-latitude jet stream pattern that the rest of the country sees. We're just on the kind of the southern end of that. And so we need to look to see the storm track to actually shift out of the Pacific Northwest into the Southwest. If we're lucky, we'll get some of those Pineapple Express storms on a strong subtropical jet. But really, we're talking about bringing in that moisture from the west, often with cold storms. This map here is just a long-term average, December to March. Humidity at the mid-levels of the atmosphere. So those purple colors would be more humid air. Reds are drier air. And you can see that the East Pacific is typically quite dry. And that's where we get winds out of the Southwest. We dry out and get those nice, warm, sunny days. And so we need to have that weather pattern out of the West shift around to actually bring that moisture in out of the West, often Southwest or Northwest, but really coming in off the Pacific out of either a colder storm track or a wetter from the tropics. So when we start to think about the summer, we're seeing that mid-latitude jet stream retreat to the north, following the sun to the north, and then we're going to get it replaced by strengthening mid-level high pressure systems and really start to participate in the subtropical tropical regime, which is really a shift around in our weather pattern and a shift in the wind from that dry southwest to south to southeast, which then opens up access to moisture from the monsoon, which hopefully is ongoing in Mexico in June, and then opening up the Gulf of California, which is really critical and important for our moisture source here in the Southwest. And so it's really about that shift. So let's look at some just progression of weather maps. Again, these are long-term averages. This is the 500 millibar, so 15 to 20,000 feet. And we can think about this in pressure patterns. You can color it and depict it in different ways. These are heights, which are going to relate to pressure patterns. And so we see that high pressure system to the south of us, really kind of tracking where the subsolar point is, where that intense heating is occurring, and to the south of it, and then the strengthening of the overturning circulation with that rising air in the tropics and sinking air just to the north of it. And that color ramp is going to tell us the kind of the intensity of those upper level winds. And so the purples to the oranges, basically the storm track is going to be in between that high pressure to the south, and as we go further to the north, lower heights or lower pressures. So this is May. Let's click forward. You can see here, sun angle is getting higher in the northern hemisphere. It's getting closer to our longest day of the year in June 21st. And that high pressure starts to build over the land masses in contrast to the ocean and build north. And you can still see that the flow in the northern hemisphere around the high pressure system is going to be clockwise. So the wind is still out of the southwest at the beginning of June. And we're looking to hopefully see in the normal progression is that high pressure build up and really get it anchored into New Mexico, Four Corners ideally. And we get into that southerly, southeasterly flow on the southern side of this high pressure system. So what that does is this is another climatological map, is we can trace where that tropical air mass really is at different times of the year. So June 15th, this is just kind of an arbitrary threshold at moisture at the lower levels. You can see it's typically in this reddish line here at June 15th, draped across northern Mexico. And you can remember it's that high pressure moves north, that flow turns from southwesterly, southerly, southeasterly. That air mass gets drawn into the southwest. And that's really what we're looking at the beginning of June with that overall shift in that circulation pattern. So what I want you in your mind's eye is hold on to that mid-level ridge. We call it Four Corners high when it's in that kind of ideal spot. That's really what we're thinking about for that canonical or that traditional monsoon flow pattern here. And so here's a cartoon conceptual graphic here to kind of show you where all those parts are. Mid-level high pressure system anchored over the four corners. And then it gets so hot in the southern Colorado River valleys, we can get weak low pressure system, and that can actually help draw warm, moist air out of the Gulf of California up into the low deserts. And so these circulation patterns occurring both at low levels and at upper levels are going to bring flow out of the east, southeast. And if there's activity in northern Mexico, that's going to help draw moisture in. We can draw it in at low levels from the east, but really we're looking for that Gulf of California to open up, put the moisture in here. We just need some sunlight and strong afternoon heating, and then we can generate that thunderstorm activity. Okay, and so as we see the progression, these are long-term monthly maps here. So these light colors in June, typically June is a dry month until we get to the very end, and you can see these just light blue colors. The mountaintops typically will see that moisture, enough moisture to actually produce convection. So we'll start to see the moisture in actual precip reaching the ground there first. July, the Mogollon Rim lights up, southeast Arizona and the Sky Islands, reaching into hopefully grabbing some of that convection in Mexico, pulling it up. August, typically our wettest month, start to see more activity moving down into the valleys if we're into deep moisture. And then usually a pretty quick retreat right at the beginning of September. That high pressure system starts to weaken and slide back south, and we lose that kind of persistent easterly flow, lose that connection to the Gulf of California, and we're usually out of it. Okay, so let's look at last summer, and then we can postulate on what might happen this year. All right, so last year, it was a very weird, very weird summer, and we can look at the map in the upper left here and just see how much precip New Mexico got, and then can contrast it with Arizona, and that lower right graphic is going to be percent of average. So those browns are below average, and you can see Arizona overall did not have a very robust monsoon. And there's a couple of green spots, which we'll talk about here in Yuma and Phoenix, and some of the lower desert areas got some precipitation. But colleagues in Las Cruces, and then if you talk to anybody who's on the kind of Great Plains side of New Mexico, crazy wet spring into a crazy wet summer and lots of precipitation. We watched at a distance, and we're kind of jealous of all that activity. And if we run it out and look at kind of the core of the monsoon season, 2025 for the summer was about 20th driest, about 3.47 inches for this bounding box up here. And you can see it's been a run of below average summers and not quite as bad as a couple years ago. 2024 beat out 2024 slightly and was just slightly better than 2023 as well. Okay, so what actually happened on the weather maps? And so this actually needs its own webinar because it was a strange summer. Is that, remember, that high pressure system really, the further north it is and the more anchored it is, and the stronger the easterly flow that Arizona experiences typically is better for us with access to moisture and storm activity. And so it looks kind of fine. And that's always the crazy thing about looking at monsoon weather maps is they all look the same, but they're all subtly different. And so the lower right, there's a couple of hints here about why things weren't so great. And this map here, there's a little weak spot. It's not even a below average anomaly, but it's just kind of normal because there's been so much warming at this level. It's suggesting that there was a anomalous low pressure system over the Southern California coast. And that's exactly what we saw last summer. It was actually unusually cool in California for much of the summer, and that nudged the monsoon ridge off to the east and the south much of the summer, and just kept us out of the kind of classical ideal monsoon flow. And if we look at where the moisture was over the whole July to September period, looks again kind of finish here where you'd normally see it, but the anomalies down here don't tell the whole story. Is that there was unusually dry air under this high pressure system anchored out in the East Pacific, which really did nudge in here much of the summer. But it wasn't until about the end of August, the beginning of September, that we actually fell back into an autumn weather pattern. And then it just started to rain. And it was crazy kind of fall, wintry kind of low pressure systems, cutoff lows that finally tapped into the moisture to the south. So really not monsoon. And so all that precip we got in September and October was really more fall-like than it was monsoon proper. And here's Phoenix's way of winning at the monsoon was to just get all of its rain in just the last couple of days with those fall storms. And I was rooting for you because in Tucson we were having a terrible summer, and I was hoping somebody get some rain, and you finally did right at the end. And so squeaked out. And this is where how we track the monsoon and the totals don't always tell the whole story, but these little blue bars show the daily total precip, and then this is from June 15th to September 30th. So just out of those big events at the end of the month, squeaking out average precipitation by the end of the month. Tucson wasn't able to do it. We were about half of what we expect with just a couple events at the beginning of the month, and then caught a little bit of that fall weather in September. Okay, so this gets interesting now, and Aaron alluded to the El Nino forming right now, and it's all if you go on social media, it's a blaze with a lot of postulation, and there is a lot of warm water in the East Pacific, and it's at depth and it's coming across, and so the forecasts now are it does seem like there's a really good chance that we will see an El Nino event forming this summer, maybe even sooner than that. And this is this graphic from Climate Prediction Center. And then even by fall, we about an even split if we're going to see a moderate to a very strong El Nino. So that'll be really interesting to talk about in the fall and the winter for Arizona. But the monsoon is kind of more present. So what does that actually mean? Well, I threw together a little viz tool down here if anybody's interested in messing around with it. It takes climate division data by months and merges it with the new CPC relative oceanic Nino index and correlates it. So this is July, August, September correlations across 70 years across all the US. And you can see the correlation ranges here are pretty low. So there aren't super strong correlations. There's some higher correlations to the north with El Nino conditions, warm sea surface temps. These areas tend to be wetter. And as you go further south here, these areas tend to be drier when there's blues. So you can see across Arizona, very weak correlations, probably not significant. The Gulf Coast, though, is kind of interesting. And I think this is suggesting that a subdued Atlantic tropical storm season associates with El Nino. We're kind of in this gray zone where we can kind of see both. And if you look at a scatter plot here, again, this is for Climate Division 7 down here in Southeast Arizona, is the correlation is very weak, lots of spread. It's just kind of weird, and I have to go back and look at the data here, but muted variability when we get into El Nino events. But just looking at the last two big ones, 2015 and then 1997, they kind of were slightly above or slightly below. So it, again, not real strong indication of we go either way. And I think there's some reasons for that. We'll talk about that a little bit. And if we just plot the July to September for Climate Division 7 precip over time since 1950, we color the bars whether they were La Nina, neutral El Nino. You don't really see much of a pattern. You can maybe squint and see red bars hanging out below zero. But if we look at the last couple of years, we've had kind of wild extremes with both phases of the El Nino oscillation. Okay, so what do we know? This is an old set of maps from Western Regional Climate Center, and I just want to point out here is that I think there's going to be a tale of two seasons in the monsoon. And so the early season, what we know from some of the literature is that it tends to reduce the risk of wet conditions in July and then shift them to the back half of the season. So these maps that are red here for July for El Nino is this here indicates this red on the left indicates there is a shift of decreased risk of wet extremes during El Nino July. And then over here on the right is an increase in dry extremes. So it's just suggesting that there's a shift towards drier conditions at the early part of the monsoon when we have an El Nino present. So let's see here. And if you look at some correlation maps, typically when you see when an event is coming on strong and is present and starting to communicate with the atmosphere, is that it tends to induce a stronger subtropical jet and even a little bit of a shift in the storm track south, which is unusual for this time of year. And it tends to nudge the subtropical ridge out of the way at the early part of the season. And that's what the research had suggested. And so that is something we certainly need to, I don't seem to think this is a slam dunk, and the outlooks are kind of moving the other direction. So I'm not super sure we have some kind of competing signals here. And then if we look at the whole season, July to September, you can see here that it washes out. And even by the risk of dry extremes actually goes down overall for the whole season, and there is no shift for the whole season for wet extremes. And I think that's because if you look at the back half of the season, August, September, October, there's an increase in wet. So it's a wash. And Aaron, I think in one of your papers, you saw this as well as kind of between the beginning and the end of the monsoon when we look at ENSO. All right, so let's just look at a couple of past big strong events here. 1983 up in the upper left, 97 upper right, 2015 lower left, and then 2023. And you can see there's a little bit of an interesting pattern here for some of those early ones. Western Arizona sees above average precipitation. 2023, certainly that case. 2015 stands out as kind of the whole area being kind of okay, average to even above average. And the 83, 97, 2023, what they have in common was really active tropical storm, landfalling tropical storms or tropical moisture incursions the end of the season. And so that seems to accompany it. 2015 was a very strange way it came on in almost a 2 year onset. So I don't know. I'm not sure where it's going to go. But the National Multi-Model Ensemble outlooks in that hangs with the climate prediction centers is showing above average precipitation all the way through Mexico, up into the Southwest and even into parts of the Rockies here. And honestly, I think what it's doing is it's picking up on an active tropical storm season. And so that can happen early in the season, typically is loaded towards the end of the season. So we'll just have to kind of see. And so Aaron already showed this part of the outlook. And the new outlook comes out this afternoon. And so we'll have to see what CPC is thinking this afternoon. Okay, so just to wrap it up here is the El Nino really is, it's going to do something with the monsoon. I'm not super sure because the correlations are weak and we can kind of go in two different directions with this. And it usually does lead to a busier second half of the season. What's interesting is that the East Pacific is very, very warm, unusually warm, much warmer than when the El Nino formed in 2023-24, which was overall dry. And it's a little more similar to 2015. And 2015 actually had strange kind of tropical moisture wandering into the Southwest even in June. And I don't know if anybody remembers, but it actually rained in the early part of June in Phoenix with some tropical waves kind of wandering up across the Southwest. So again, El Nino forecasting this time of year is still really tough. So we have to really pay attention to the forecast kind of every week into the couple of months as we get closer to the monsoon. And this is a strange event. I mean, it's got a lot of warmth. The overall Pacific is very warm. And so there's not great analogs with this. 2015 is similar, but not totally because it really started in 2014. So I do think this will be really interesting and kind of fun to watch over the next couple of months. So I'll leave it there and thank you.
Thank you so much. That was an excellent discussion. And yeah, we're all going to need to have our buckets of popcorn in front of the computer and keep our eyes on all of this. So thank you so much for all of that. I appreciate that.